Hello, thank you for checking out A1 Math, and today we're looking at solving systems of linear inequalities um, by graphing. We're going to do it with a special system of inequalities and just a regular system of linear inequalities. So let's begin. All right, so got a couple examples here. One is already done for you, but I don't want you to go to the trouble of trying to figure out what points are in or out. Just understand that the part of the region that's shaded in twice is the solution. Okay, so let's take a look at this first example. So it's really simple. All you got to do is make sure that both of your equations are solved for y. So you see this one's already solved for y, and this one's not. So once you go ahead and work it out, solve it for y, and get both of them solved for y. Then you're going to graph the equations like so, and then see what the shaded in region is. That is the part that's shaded in by both inequalities. That is the actual solution to the inequality. All right, let's take a look at another example. All right, so in this example here, I've got one equation already solved for y, so I've already got that one here. And then I got this one, I need to solve it for y, so let me do that. So what I'm going to do is I'm going to subtract the 3x on both sides. And then that's going to leave me with a negative 3x plus 1. So keep in mind that if you had a coefficient in front of y that's other than positive 1, you would have to divide. And also keep in mind if it's negative that you would have to swap around the inequality. But now I have both equations solved for y, and my second equation is negative 3x plus 1. Y is less than or equal to negative 3x plus 1. Now the next thing I'm going to do is go ahead and graph them. Okay? And you got to be careful on this graph because they are um, one block equals 2 units. So you're going to count half a block as 1. So I'm going to start the y-intercept. And this one I'm going to keep red. And I'm going to change the colors on the other one. But this one here is just going to start here at 1. Actually, positive 1. Okay. And then we're going to go down 3. Remember, count half blocks as 1s. 1, 2, 3. And then over 1 block, which is a half a block. And then we're going to draw a line there. I'm going to go up and over just to get another dot here. And draw a line. And because it is a equal to, we're going to use a solid line. All right, now, since it's less than, we're going to shade below. So I'm going to shade below like so. All right, next, we're going to do this one. It's already worked out for us. We're going to go to negative 2, which is, remember, the count half of blocks is 1. 1, 2. And we're going to go up 2 and to the right 3. So I'll go up 1, 2, and go to the right 1, 2, 3. Go up 1, 2, and then go to the right 1, 2, 3. And since this is not equal to, we're going to put a dash line. Okay, and since it's greater than, we're going to shade above. Okay, and there's a couple ways to go about it. You could either erase the part that doesn't count, or you could just really shade in the other part here. I'm just going to really shade in this part here. But that is where the solution is, in that area. All right, let's take a look at another example. Okay, so for this example, both of these are already solved for y. And all I gotta do is graph them and see where they overlap at. So here I've got y is less than -3. So I'm gonna go ahead and graph that one real easy. So I go down to -3, 1, 2, 3, which is right here. And since it's not equal to, I'm gonna draw dash lines. All right, now I'm gonna do the other one here. And the y-intercept of that is +3, which is right here. And it has a slope of 1. So I go up 1 and over 1, up 1 and over 1, up 1 and over 1, down 1 and back 1, down 1 and back 1. Right? And since it has an equal to, I'm going to draw a solid line. Okay. Now I forgot to shade in on the other one, so let me go ahead and shade that. Since it's less than, I'm going to shade down. And since this is less than, I'm going to shade down as well. So where they overlap is in this region here. And just that's how you do a system of linear inequalities. So take a look at number 4 here and see if you can graph this. Okay, let's take a look at number 4 here. I'm going to zoom on in. And the first thing I'm going to do is go ahead and solve for y on this first one here. And I'm going to subtract the 2x on both sides. It's going to give me 4y. It's less than -2x plus 16. And since I subtract it and not multiply or divide, I don't have to swap around inequality. So next thing I'm going to do is go ahead and divide the coefficient here, which is 4. That's going to leave me with y is less than -1 over 2x plus 4. So now I have both of my equations. I have this one up here, and I have this one right here. And I'm going to go ahead and graph the one I just worked out. So I'm going to start off at +4, and go down 1 block and over 2. Down 1 block, over 2. Down 1 block, over 2. Or go up 1 block and back 2. Okay, and since it is not equal to, we're going to use a dash line. So now I'm going to go ahead and do the first equation, first inequality up here. I'll go down to -8. It's got an understood slope of 1 over 1 here. So I go up 1 over 1, up 1 over 1, up 1 over 1. And that's also not equal to, so I'm going to use dashes on that one. Okay. Now, this blue one here is greater than, so it's going to be everything this way. But the red one here is less than, so that's going to be everything below it. And where they overlap, which is in this area here, is the solution. Okay, so that's solving inequalities there. Now we're going to take a look at some special cases. Okay, so this is graphing system of inequalities with parallel boundary lines. So we'll take a look at these, okay? So if you take a look, we've got two equations with the same slope. And anytime you get the same slope, you end up with parallel lines, which means they're not going to intersect, okay? So let me zoom in here and make sure it's real clear what we got going. So they went ahead and worked this one out. So they started at -3 and went up 4 and over 1. And then they went to +2. Actually, I was at +2, but +2 and go up 4 and over 1. So we got the two lines. On this equation here, on the +2 equation, they said to shade greater than, so they shaded this way and left it dash. On the other equation here, it starts at -3, which is right here, and went up 4 and over 1, up 4 and over 1. But it said to shade less than, so it shaded this way. So since it doesn't overlap, then there's no solution for this one. Okay, let's take a look at this other one here. Okay, so I'm going to graph both of these, and I'm going to start with this one. And I'm going to go to -2, and it has a positive slope of 1. So I'll go up 1 and over 1, up 1 over 1, up 1 over 1, up 1 over 1. And you're just going to keep going here. And since it's not equal to, we're going to use dashes. Okay, and since it's greater than, we're going to shade above. Okay, now on this next one here, we're going to go to +4, which is right here. It also has a slope of uh, up 1 over 1. All right, and it is equal to, so let's make that one solid. And it says to shade down. Okay, now on this one, the part where they overlap, same as the other ones, is where it's solid, or where the solution is. So the solution is in between here. Mhm. That's how you do those with parallel lines. All right, take a moment and see if you can solve these two. And they're already solved for y. You just got to draw them out and see where they overlap. All right. So on 5 and 6, this should be what you get. Okay, you have one that overlaps here and has a solution on this side. And then you have another one that has no solution. And that's it. That is graphing a system of inequalities. I want to thank you for checking out A1 Math. Have a nice day.